Hello everyone, welcome back to my YouTube channel Liang Crackers for Cracking IIT and NEET. So today in this video I am going to discuss about GOC, General Organic Chemistry, which is a major part in organic chemistry, of course in reaction mechanism. So most of the students are getting confused in solving organic chemistry, how to predict the trends like acidic nature, basic nature, carbocation stability, carbonium stability, and what is the expected product through any reaction mechanism. So every reaction mechanism is based on only two factors in organic chemistry. Those are non-polar and polar bond. So in the influence of your polar, what is the change in non-polar bond? So depending upon that one, whether it is getting less electron density or more electron density, so that is a factor. Second factor is what? En concepts. Second factor is what? En concept, electronegativity. Actually we may consider only individual elemental electronegativity, but that is wrong, absolutely wrong in organic chemistry. So what is the En concept and what is this non-polar polar generation, that we will see one by one. So if you want to know about these concepts, we must know few effects in GOC. So what are those effects in GOC, general organic chemistry? In GOC, general organic chemistry, so the types of effects, how many effects are there? So what are those? One by one we will see now. So the types of effects, first one is what beta here? Electron displacement reaction. Electronic displacement reaction, which means what here? Generation of polar in the influence of what? Polar bond. That is what electron displacement method. How many are there? That we will see. Second one is what here? Sterical effect. Sterical effect. Second one is what here? Sterical effect. Sterical effect. Third one is the solvation effect. Third one is what here? Solvation effect. What is that? Solvation effect. The fourth one, last one is what? Chelation effect. Chelation effect. Chelation effect. Of course, this chelation effect is not there in UG. So it is present in PG level. So that's why no need to consider this point. But we must consider this electronic displacement effect, sterical effect and solvation effect. Actually, most of the times we may consider only electronic displacement effect, which means here electromeric effect, and next one is what? Plus A effect, minus A effect, mesomeric, resonance, everything is under electronic displacement effect only. So based on those effects we may find a trend of acidic nature or basic nature or carbocation stability or maybe carbonyl stability, but that is absolutely wrong. We no need to consider this only single, so we must consider all the factors. What are those? Electronic displacement, sterical effect, next one is what? Solvation effect. We must consider all the factors. Only we are considering one point, this one, that is absolutely wrong. So let's see one by one. So if you observe multi effects, then how to find the trend? Okay, first one here, electronic displacement. How many types of electronic displacement reactions? So actually there are two types of electronic displacement reactions. There are two types of electronic displacement reaction. First one is what? Through bonds. First one is what here? Through bonds. Through bonds, sigma bond or pi bond or whatever, through bonds. Second one is what here? Through field effect. Through field effect. This is also we are not considering, only we are considering through bonds only. That is absolutely wrong. We must consider each and every factor. Each and every factor. Electronic displacement is being divided into what? Two types. Through bonds. Through bonds, electron displacement. Next one is what? Through field effect. This is called what? Field effect. Again now, through bonds, how many types are there? Through bonds, how many types are there? So these again two types. It's been divided to two types. First one is what here? Permanent effect. First one is what? Permanent effect. The second one is what here? Temporary effect. So second one is what, beta? Temporary effect. So this is the deviation of all the effects. So electronic displacement, two types. Bond, next one is field effect. Again bond is being divided to two types. Permanent effect, next one is what? Temporary effect. Now in permanent effect, what kind of effects are there? Yes, all the possible, whatever we know, all are present here only. Permanent effect, what is that? Inductive effect. First one is what, beta? Inductive effect. What is the second one? Second one is what? Mesomeric. Mesomeric or of course resonance. Mesomeric or resonance. What is the difference between meso and reso? That we will see later. one by one. Third one is what here? Aromaticity, aromaticity or aromatization. So here you have to choose the aromatic and non-aromatic, anti-aromaticity. Overall, that is the aromaticity concept. So last one is what here? Hyperconjugation. Of course, hyperconjugation is also having two types: hyperconjugation and reverse hyperconjugation. So one by one, every concept we will discuss clearly, no problem. I am here to teach you all types of concepts and short tricks. How to find, after that how to find the trends, all possible trends. Next one is a temporary effect. Temporary effect, only one is there, that is what? Electromeric effect, beta. What is that? Electromeric effect. Electromeric effect. So these are the possible effects in organic chemistry. Effects are, every effect is present here. If you practice all these effects perfectly, then you will be able to find the trends. Maybe acidic nature, maybe basic nature, maybe carbocation stability, maybe carbonium stability, maybe rate of reaction, which means like electrophilic addition, nucleophilic addition, substitutional reaction, elimination reaction. Everything you will be able to find the reaction mechanism if you know all these factors properly. If you know all these factors properly. So this is the overall chart of effects which are present in GOC, General Organic Chemistry. So look at the board once, check it all. First one is what? Electronic displacement. Second one is sterical effect. Third one is salvation effect. Last one leave it. And now electronic displacement begin what here? Bonds and field effect. Next one is being divided to two types: permanent effect and temporary effect. So permanent effect, inductive. Of course, what kind of inductive? Plus or minus, one by one. Next one mesomeric. In mesomeric, what is the stability order of or contributors, that we will see. Next one is aromatization. Last one is what? Hyperconjugation. So temporary effect is what? Electromeric effect. This is what, beta? Electromeric effect. Actually, what is the difference between permanent and temporary effect? So permanent effect is nothing but whether the reagent is present or absent. In the influence of what is that reagent or in the absence of reagent, there is no change in effect. There is no change in effect. So that effect is called what here? Permanent effect. But is a temporary effect in the influence of any reagent, external reagent only, your effect is generated. If you remove that, then it can lose its effect. That is called what here? Temporary effect. This is the weakest effect. Of course, here one more thing. One more important thing here. Field effect is a weak effect. Field effect is a weak effect. And inductive is also a weak effect. Inductive is also a weak effect. Next, remaining these three are stronger effect. These three are strong, and the electromeric, of course, it is a weaker effect. It is a weaker effect. And one more important point here: wherever you observe in a given molecule or whatever the trend, inductive effect plus field effect, inductive effect plus field effect, then it gives 100% exception order. 100% exception order. This is opposite to the normal trend what we are thinking. Maybe acidic, maybe basic, maybe stability, whatever. This is exactly opposite to what here? Normal trend. Inductive plus weak field effect. Inductive plus field effect. So this is very important, this point. Okay. Now let's see here one by one. So electronic displacement. So here permanent effects are there one by one: inductive, meso, aromaticity, hyperconjugation. What are its applications? And electromeric effect, of course, it is not important, but we will see. Next one is what? Here spherical effect. Spherical effect, actually here there are two types spherical effects. So here SIR effect, SIR effect, SIR effect, and next one is what here? SIP effect. SIR effect and SIP effect. So of course, SIR effect and SIP effect is applicable for all factors better. Even what here, stability of carbocation, these two are applicable. Stability of carbonions applicable. So next one is basic nature, next one is acidic nature. Everywhere the spherical factor is very important, which we may not consider this one, but we should consider all factors. Then only you make it the correct trend, correct answer. Last one is the salvation effect. Salvation effect, most probably basic nature of amines, basic nature of amines in +1 +2 syllabus. So many factors are there, but here in +1 +2 salvation effect is for what? basic nature of amines in aqueous solution. In aqueous solution, so what kind of effect is there? Maybe 2 degree, 3 degree or whatever. So like this, all factors we must consider. Now let's see one by one. What is the first one? Inductive effect. What is the first one here? Inductive effect. What is this inductive effect? What does it mean here? Inductive effect in organic chemistry. Uh, let's take one example in inorganic chemistry. In inorganic chemistry, actually we know if you take here Br is Br2 molecule. Of course, it is non-polar. 100% non-polar bond. Yes or no? It is 100% non-polar bond. Now, if we take here water molecule. So water is having what beta? Dipole moment. So here partial negative charge. Dipole is not equals to 0, which means water is a permanent dipolar molecule. Permanent dipolar molecule. Now here this Br2 is actually non-polar molecule. That we know. Here if you think individually, this is separated polar molecule. This is also separated non-polar molecule. But if we mix both of them, what will happen here? What will happen? In the influence of this polar, so here charge is generated, because here partial negative charge, that's why. So here partial positive charge is generated. So if it is partial positive charge, it's becoming what here? Partial negative charge, which means in the influence of polar bond, in the influence of polar molecule, here non-polar is being converted to polar. So this polar is called induced polar. This polar is called what here? Induced polar. This is what beta? Induced polar. Is it clear? Check it. In the absence of this water molecule, Br bond is what here? 100% non-polar. But in the influence of this one, here polarity is generated. That polarity is what here? Induced polar. So if we apply this concept in organic chemistry, let's see what will happen here. Carbon I am taking here carbon separate, and carbon Cl or Br separate, right? Now here carbon, so En difference is 0. That's why it is what here? Non-polar. This bond is of course non-polar. Right? Now here Cl bond, En difference is there. It is what here? Polar. Now just in a single molecule, if we attach in a single molecule carbon, Cl, right? Is it clear? Check it. Carbon, Cl. Now one thing. Here what is happening? This bond is already polar. Because of En difference. So partial negative charge. Now here what is that? Partial positive charge. So before that condition here, this Cc bond is a non-polar. Let's see now this Cc bond what will happen. This Cc bond what will happen? Let's see. Now one thing here, electronegativity concept. Electronegativity is of course directly proportional to what here? Positive charge. Why positive charge? If positive charge increases, Z effective increases. If Z effective increases, which means what does it mean here? Z effective. So polarity of sigma or pi bond towards nucleus is increased. That is called what here? Electronegativity. That's why electronegativity is directly proportional to what is that? Positive charge. For example, if we take one element, A or B, one element, what is the overall electronegativity order? This order is very important, beta. It is now here A complete charge is more electronegative than partial positive charge. Next one, of course, it is more than neutral. Next, if it is more than partial negative charge, next it is more than what here? Complete negative charge. Of course, you may take like this, A minus 2. This time, this side also A plus 2 also you may take. More increasing positive charge, more it is having what? Electronegativity. More it is increase what here? Negative charge, lesser electronegativity. So that is the order. Now use that application here. Here this is what is actually Cc, this is 0, this is 0, this is 0, this is 0, but this one is what? C partial positive charge. 0. So which is more electronegative element? This carbon is more electronegative element. That's why here bond is polarized towards this carbon. Now here, after losing electron density, this carbon is getting partial positive charge, but this partial positive charge electron density is lesser than this one. Why? Because this is directly connected to more electronegative element. This is connected to electronegative element compared to this one, but not that much. That is the problem here. Okay. Now this is 0, this is C positive, of course partial positive. Okay, partial positive and 0. Now it can act as more electronegative element than this neutral carbon. So now it is polarized. Now it can generate, what is the charge here? Plus. See here, the magic of this polarity. Now see, before that it is a non-polar, before that it is a non-polar, now it is becoming what? Polar. So this polar bond is called what here? Induced polar bond. That induced polar bond in organic chemistry is called inductive effect. What is this? Inductive effect. So what is inductive effect in the organic chemistry? Simple trick. There should be one polar bond. There should be definitely one polar bond. So in the influence of polar bond, if non-polar is becoming polar bond, so that non-polar bond is called inductive. That non-polar, whatever the non-polar bond is there, so that is called inductive effect. So this is the introduction or concept of inductive. Is it clear? Check it, is it clear? In the influence of polar, there should be generation of non-polar. There should be generation of polar from non-polar. So that non-polar bond is called here what? Inductive effect. This is inductive. This is not inductive. This is not inductive. This is inductive. Generation of polar. What is that? Polarity of non-polar. So the non-polar bond is what here? Inductive. For example, if I ask you one question here, HCl, whether it is having inductive or not, inductive of bond or not? No. Inductive is nothing but relative thing. Inductive is what? Relative thing. In the influence of polar, generation of polar from non-polar. That is called here inductive. Of course, it is 100% polar. Yeah. Of course, it is 100% polar because already it is what? En difference is there. En difference is there. Yes. Here partial positive and partial negative charge. This is polar, but not induced polar. Polar, but not induced polar. So in the same way, one more example here. CH, methane is there. So CH, every bond is what here? Non-polar only. Every bond is what here? Non-polar. So one more example of chloro or fluoromethane. I am taking here for example fluoro. Now here this is what? Hydrogen. Now here it is also hydrogen. So let's see the difference between these two, or this CH bond, what will happen here. Now CH, of course here En difference is very less. En difference, because hydrogen is having nearly 2.12 something and this is having nearly 2.45 something. So En difference is nearly equals to 0, means it is what? Complete more covalent in nature. So non-polar. 4 non-polars. Complete it is non-polar bond. Right? Now here also normally if you don't think about this one, CH bond is non-polar. This is also non-polar normally because En difference, according to En difference. But what is happening here practically? So here in between these two En is generated. Now fluoro is what? More electronegative element. So it gets partial negative charge. So what is the carbon charge beta? What is the carbon charge here? Partial positive charge. So this is C plus. This is hydrogen. Of course, one thing we know, in between C partial positive charge and C neutral, which is more electronegative. So which means here electronegativity is increased. If it is increased, then En difference is also increased. If En difference is increased, C plus is more electronegative than hydrogen. Now here it is polarized. So partial charge is generated. See here, this is non-polar, this is polar, non-polar, polar. But if you think here CH is what here? Non-polar. So what is happening here? Non-polar is being converted to polar. So that bond is called what here? Inductive. Is it clear beta? So depending upon that polarity, either polarity towards other element or towards hydrogen, so that we have to decide plus I or minus I effect. Okay, plus I or minus I effect. Normally, how to find plus I or minus I effect? So before going to discuss about plus I or minus I effect, if I ask you one simple question, what is the effect of methyl? Either plus I or minus I. Of course, you know the introduction of plus I and minus I. What is the effect of methyl? Plus I or minus I? Think and send me the answer in the comment box. CH3 role is what here? CH3. Of course, most of the students may say, sir, it is alkyl group, sir. It is alkyl group, sir. Plus I, sir. It is alkyl group, sir. Plus I. Wrong. Wrong. Absolutely wrong it is. We cannot decide immediately. We need one more what here? Relevant thing. We need one more what here? Reference. Based on the reference, you may decide whether it is having no inductive or positive inductive or negative inductive. Let's see here clearly. First one here CH2. Next one is hydrogen. Means this CH3 effect. Let's see what is happening here. First example is ethane. Second one is what here? CH2. Next one is hydrogen. Next one is what here? NeO minus. Next one is what here? CH2 and hydrogen bond. Next this side is what here? Any fluoro or chloro. Any fluoro or chloro. So first one, check it here. Here polarity check it. This CH bond polarity check it, because CH is non-polar normally. But in the influence of other elements, what will happen? That is a matter here. Of course, CH bond is a non-polar. CC bond is also non-polar. Here, CH bond is also non-polar. Every bond is non-polar. Yeah, there is no the presence of what polar. Actually, is what inductive is nothing but there should be at least one polar bond. But there is no polar bond. Then there is no generation of polar. So what is the bond of this one? Zero inductive. There is no inductive. There is no induced polar. What is the effect of CH3 here? Zero. Next here, this is what? Electron excess. Electron excess is nothing but it is what? Donating group. Then here hydrogen, towards hydrogen electron density is polarized. Yes, polarity is generated in the, see, this is not induced bond. This is already polar bond. This is the induced bond. In this induced, so polarity towards which one? That is the matter. So now it is, what is the effect of this one? Minus I. Minus I of which one beta? Minus I. In the influence of O minus. In the influence of O minus, CH3 is having minus I effect. Next one here. So it is what? Electron withdrawing group. Already CF bond is a polar. In the influence of polar, here generation of polarity. So this is called what? Induced dipole. So here electron withdrawing group. Electron withdrawing group. So what is the fluoro effect on methyl? Minus I. Minus I. Okay. So like that we have to find the inductive effect, whether it is plus I or minus I. There should be one relevant or reference. So based on that reference only we can decide whether it is having no inductive or plus I effect or minus I effect. Actually plus I or minus I, so depending upon the electron donating and electron withdrawing group beta. For example, here one group is there, so it is what? Withdrawing group, because what is the role of this one? Electron withdrawing group. Then in the influence of electron withdrawing group, so it is having what here? Minus I. We have to say what here? Minus I effect. So if any group is present in the organic cloud, now that group is donating electron density. So what is the role of that one? Electron donating group. Then that G is called what here? Plus I. It is having plus I effect. So like this we have to find. And the influence of electron withdrawing group, that is minus I. In the influence of electron donating group, that is what here? Plus I. So one thing here, small factor here, short note. So due to electron withdrawing group, electron density on carbon cloud What happened here? Partial positive charge. So electron density decreases. What will happen here? Due to minus I, electron density is decreased. Here due to plus I, so it's getting what is the charge here? Partial negative charge, because this is the donating capacity. More electron density, it is getting more electron density. So that's why here electron density is being increased. So electron density is increased here in plus I, in minus I decreased, in plus I increased. Now let's see one by one here. What are the factors of groups of plus I? What are the factors of groups of minus I? Then how to apply? What are the applications of this plus I and minus? Wonderful. So first one is what, beta? Plus I effect. First one is what here? Plus I effect. So plus I effect, first factors. First we have to know the factors. Then no need to remember the trend which is mentioned in the book or textbook or somewhere else. No need to remember the trend. If you know all these factors, then you itself what you can find out that what order. Whatever the four options are given, how to find out the trend, basic nature, acidic nature, carbocation stability. So you can find the elements, what kind of effect is there if you know these factors. So these are very important factors. First factor is what here? Excess negative charge. Important factor is what here? Excess negative charge. Second factor is here lesser electronegativity than carbon. Lesser electronegativity than carbon. Next one is what here? Alkyl groups. Among alkyl groups, how to find the order, that I will give one shortcut here. Next one, last one is what? Isotopes of hydrogen. Isotopes of hydrogen. So actually, practically, one reference thing is required. That reference is what here? Beta hydrogen. Hydrogen practically having zero inductive effect. There is no polarity towards it or towards other element in the influence of hydrogen. There is no effect of hydrogen practically. That's why it is a reference thing. So what is the value inductive effect? Zero. Practically hydrogen is having zero. Now let's see one by one plus I effect components. So this is the order beta. First thing is what? More plus I effect component is what? Excess negative charge, because it is excess negative charge. So it can donate electron density easily. Donating electron density, what is the nature? Plus I effect, because it is having excess. So it can donate easily more electronic cloud. That's why it is what? Stronger plus I component. Second one is what? Lesser electronegative than carbon components. Third one is what? Alkyl groups. So among alkyls we have different degrees. How to find? I will give you one shortcut. You should remember that one. You will be able to find out all types of bulkier alkyl groups plus I order. Next one is what here? Isotopes of hydrogen. So isotopes of hydrogen we have what? Deuterium and tritium. What is the order of this one? One by one we will see. First one is what, beta? Excess negative charge. So excess negative charge, one factor here, plus I effect is directly or inversely proportional to electronegativity. Inversely proportional to electronegativity. Plus I effect is what, beta? Inversely proportional to electronegativity. Lower electronegative, then it can donate. If it is more electronegative, it can accept. That is called withdrawing group. But here we need what for plus I effect? Electron donating group. So overall concept is what here? Plus I is inversely proportional to electronegativity. But here is very important. What kind of electronegativity? We have few electronegativity concepts. If you understand thoroughly that what is that particular thing, then only you will be able to solve this problem. That electronegativity effect we will see later. First thing here, excess negative charge. One example, O minus, N minus. O minus, N minus. Of course here negative, here negative. That electronegativity order is directly proportional to positive charge, inversely proportional to negative charge. That we know already. So which means here these two are lesser electronegativity, that is okay. But in between these two, minus is having same charge, leave it. Then O and nitrogen. So in between these two, nitrogen is more electronegative or less electronegative? Less electronegative. That's why it is having stronger plus I effect. So we are discussing plus I beta, careful. So it is having stronger plus I. Okay, in between O minus and S minus. In between O minus and S minus. Yes, S is having what? Lower electronegative. S is having what here? Lower electronegative than oxygen. That's why it is having more plus I effect. Next one. Here overall order like this. CH2 minus is there. Next one is NH minus. Next atom O minus. Okay. Fluoro is not having because fluoro is having monovalent bond only. So it should be connected to already alkyl. There is no other effect. Leave it. Now CH2 NH2 O minus. Minus minus is same. Then C is lower electronegative. So stronger plus side. Next, this is strong. This is the order of negative charge. So one more order is there here, carboxylic acid. Carboxylic acid. Carboxylic acid. So this is the overall order of the excessive negative charge. One trend is over. One trend is over. First one is what better? Excess. Excess negative charge. Excess negative charge is over. Second one is what? Second one is lesser electronegative than carbon molecule. So what are the molecules? SiR3, SiR3 and MgR or MgX. MgX. So this silicon magnesium are having lower electronegative than what here carbon. So these are showing plus I effect. In between these two, plus I effect is like this. In between these two, plus I effect is like this. Why magnesium? Why silicon like this? That we will see. That is based on the electronegativity concept. Electronegativity concept. So what is the electronegativity concept? Overall, there is what is the electronegativity concept here? What is the electronegativity concept? So it's been divided into three types. This is very important. Okay, first one is what? Elemental. First one is what? Elemental electronegativity. Second thing is what? Group electronegativity. What is that? Second one, group electronegativity. And the last one is what? Last one is what here? Modified electronegativity. Modified electronegativity. So this is very important. Modified electronegativity. What does it mean? After all possible effects, what is the final electronegativity? That is what? Electronegativity modified. So this is very important here. That electronegativity is here modified. In organic chemistry, we have to select this modified electronegativity. We have to find first modified electronegativity. Later, what kind of effect? Plus I, plus M, minus M, resonance, whatever it is. So this is very important. Even in the rate of reaction, even in the reaction mechanism. So this is the most important factor. Modified electronegativity. What is this elemental electronegativity? Elemental is nothing but generally according to periodic table: carbon, nitrogen, oxygen. So from left to right, En value what happened? Increased. En is increased. That we know. This is called elemental. But we don't have any elemental because here organic compound is a molecule, compounds. So means there should be at least two types of carbons, two types of what? Atoms. So this is not elemental. This is not elemental. Here maybe is there. Something bond is there. So what is the overall electronegativity of that carbon, that hydrogen? That is different. This is not elemental. So here elemental is not valid. Elemental is not valid in organic chemistry. We should not select here elemental electronegativity concept. Second thing is what here? Group electronegativity. Actually group electronegativity, the difference electronegativity is directly proportional to group electronegativity. So this is what group electronegativity concept. The difference of the bond between any AB molecule or BC molecule. So that is called what? Directly proportional to group electronegativity. What does it mean? One example here, cyanide is there. C triple bond N. Next one is what? CF3 is there. Next one is what? CF3. Now, if you think carbon nitrogen, carbon fluoride. So fluoride electronegativity is more. Of course, that is nearly 3.94. This is 2.5. It is 2.53. Now here we make it more En difference. So more En difference, more it is having group electronegativity. So this is a group electronegativity. If group electronegativity is increased, then minus I is also like that only, because minus I, what is that here? Directly proportional to what is that? More electronegative. That we will see this one minus A effect component. Okay, so this is what here group electronegativity concept. Group electronegativity is nothing but del En is directly proportional to group electronegativity. So what is the application of this one? This is applied in mostly minus I effect. Minus I effect. There we will see. Now what is the modified electronegativity? Modified electronegativity. So this we will see in minus I component. So there are three types of En concepts: elemental, group, modified. So practically we should not select elemental electronegativity. We should not select group electronegativity. We have to select the final after all possible effects. What is the modified electronegativity? That we should consider. So based on that electronegativity, if that element or group is electron withdrawing or electron donating, so that is a matter depending upon that one, whether it is favors for plus I or minus I. Okay, that we have to find. Now here, third one is what beta? Lesser than carbon is over. Last one is alkyl. So in alkyl groups, I will give one shortcut. Simplest shortcut, but which is very important. First one is what? D. Next one is what? B. Next one is what? N. This is called DBN rule. DBN rule. DBN. What is D? What is B? What is N? D stands for distance. Suppose minus I or plus I. I effect is what? 100% distance dependent. 100% what? First factor is distance. Distance dependent. Distance dependent I effect, whether it is plus I or minus I, because it is sigma polarized. Sigma polarity in the influence of any polar bond. So I is definitely directly proportional to what? Distance. Okay, whether it is plus I or minus I, first factor is distance. Next factor is what here? Of course, we are discussing what here? Plus I effect. That's why for plus I effect, plus I is directly proportional to distance. Directly proportional to distance. Again plus I. Plus I second thing is what here? Branching. Number of carbon branches. Number of carbon branches. Third one, number of carbons. Number of carbons. So this is very important. Rule careful better here. DBN. First we should select distance. If it is same, then go for branch. If it is also same, then go for number of atoms. So step by step, first we should select only distance. Okay. One example. If we take here 4 carbons. Next one is what here? 4 carbons. Next one here also number of carbons are 4. Right? So now what is the plus I effect order? So plus I effect order, first factor is what? What is the first factor? Distance. So this is actually here one organic cloud is there. Here one organic cloud is there. This bond is nothing more. It should be connected to organic cloud. So this organic cloud and this is connected to this carbon. So this is our what here? Targeted carbon, a targeted element, whatever it is. Now here also it is what? Targeted element. Here also it is what? Better targeted element. Now distance is the first one. First carbon. Distance is same. Now next one is what? Branch. Next one is what? Better. So this is what? Only one type of branch, because this carbon is connected with only one type of branch. Now this carbon is connected with 1 and 2. So total how many branches are there? 2 branches. Now the last one, this carbon is connected with 1, 2, 3. So 3 branches are there. First one, distance is same. Leave it. Then the second factor is what here? Branching. So branching means which is having more branching? This one is having more branching. That's why it is having more plus I effect than this one. This is having more plus I effect than this one. So this is called DBN rule. So based on DBN rule, you can find whatever the alkyl group is there, whatever the number of carbons are there. So you can find the order of the plus I based on this one. DBN, very important thing. Is it clear, beta? Distance. Next one is branching. Next one is number of carbons. Next one is what? Number of carbons. One more example is like this. If we take here 4 carbons or 5 carbons, next one is here is like this. A number of carbons, how many? 5. Next one here is like this. Of course, here number of carbons 5. Next here is like this. Number of carbons are 4. Number of carbons are 4. So first factor is what? Targeted element. Targeted element. So this one, right? This one, right? This one, right? This one, right? Now first one is connected with linear. This is linear. Next one is what here? This is also linear. Next it is having branching. Here nothing means this is having two branches. This one is having two branches. Okay. First one is over. So this is having what? More plus I effect. Next carbon, second carbon, second carbon, second carbon, second carbon. Now here second carbon is having extra branch. So that's why it is having what here? Second order. So first one, second one. Now in between these two, of course, two are linear. Two are linear. But this is having more number of carbons. More number of carbon. That's why it is a third one. This one is the fourth one. So this is the order of psi of the given alkyl groups. Whatever the alkyl, you can find out the psi effect order. Is it clear? Better check it. DBN rule. Apply DBN rule. You will be able to find yourself. Right? Clear? The last one is what? Isotopes. Last order is what here? Isotopes of hydrogen. Isotopes of hydrogen. Isotopes of hydrogen. So how many are there isotopes of hydrogen? Hydrogen is there. Next one is deuterium is there. Next one is what? Tritium is there, right? So now if it is connected to carbon, carbon, right? Of course, the mass order of hydrogen isotopes, tritium is heavier than deuterium, deuterium is heavier than hydrogen. If mass is increased, then bond length is decreased. Now CH, CD, CT, of course these three are donating capacities. Donating atoms. Why donating atoms? Just EM difference. So carbon is more electronegative than hydrogen. So slightly it can donate. So hydrogen D and T are having what? Donating capacity. So donating capacity is nothing but plus I. So these three are under plus I. That is okay. What is the order among these three? So mass increased. Distance, bond length, what happened? Decreased. Which means here this is the shorter bond. This is the shorter bond means electronic cloud polarized towards carbon is maximum because it is shorter bond, very short. So now which can donate more electron density? Tritium is first. That's why what is the order? What is the order of plus I among isotopes of hydrogen? Tritium is greater than deuterium is greater than hydrogen. So this is the overall order of plus I. First factor is what? Excessive negative. Second factor is what? Lower electronegative than carbon. Third factor is what? Alkyl. Alkyl we have to use the DBN rule. That's it. Use it there. DBN. Whatever. No need to write 2 degree, 3 degree, whatever. Just put DBN rule. Apply DBN rule. Whatever the alkyl. Last one is what here? Isotopes of hydrogen. Isotopes of hydrogen. Now what is the overall order? You can find yourself. Am I right? You can find first one excess what is the trend? Put here. Second one is what? Lesser electronegative. Put here this one. Next one is what? Alkyl. Just use the DBN rule. Last one is what? Hydrogen, deuterium, tritium. What is the order of that one? Mix all this. Put it at once. That is the overall order of plus I. Let's see at once. What is the overall order of plus I? Here one thing. This simply this is DBN rule. This last one is this one, right? So what is the overall order? What is the overall order of plus I? First one is what? Excess electronic charge. What here? CH2 is greater than. Next one, NH is greater than. Next one, O minus is greater than COO minus. First it is over. Second one is what? Lower electronegative than carbon atom, SR. Next one is NGX, NGX. Next one is what? Alkyl. Just I am taking for the sake of understanding here. 3 degree greater than 2 degree greater than 1 degree. But actually my rule is what here? Deviant. Use this deviant rule. Next one, hydrogen isotopes. Tritium. Next one, deuterium. Next one, hydrogen. Yes, that's it. That's it. Oh, it is over. Plus I effect order is over. So this is the overall order of plus I. So how to apply? What are the applications of this plus I in organic chemistry? That we will see after discussing about that minus I effect also. So next one is minus I effect. Next one is what better? Minus I effect. So what are the factors of minus I effect? What are the factors of minus I effect? So opposite to plus I, actually minus I is what? Electron withdrawing group, which means it should be more electronegative element. So overall more electronegative molecule or element, but this more electronegative is what here? Modified. It should be modified. Now this is the matter how to find the modified electronegativity. We will see. The first one is what here? Highly positive charge, opposite to plus I. Highly positive charge. First one is what? Highly positive charge, electronegativity. Second one is what? Partial positive charge, electronegativity. Partial positive charge, electronegativity. Third one is what here? Third one is what? Neutral electronegativity. Electronegativity element. Maybe halides, maybe OH, maybe NH, something, whatever. We need to find here. Okay. Now this is the order actually. Highly positive. Next one partial positive. Next one here neutral positive. So here the application is applied modified electronegativity in these two conditions. Okay. So first let's see one example. Simple thing. Electronegativity. So see this one is what? Minus I is directly proportional to what? Electronegativity. That is particularly modified electronegativity. Modified electronegativity. What is this modified electronegativity? One example, if we take here OH and iodo, of course we know elemental condition, oxygen is more electronegative than iodine. Oxygen is more electronegative than iodine. So you may say like this, OH is having more electronegativity than iodine, more electronegative, and is what here? More minus I effect. So we may expect here what is the order? Hydrogen OH is greater than iodine. Wrong. Wrong. Absolutely wrong in minus I. Absolutely wrong in minus I. We are discussing minus I, modified electronegativity. Okay. Next one is what? C cyanide. C triple bond N. Next one is what? CF3. Next one is what here? CF3. So more En difference. Which one is having more En difference? CF3 is having more En difference. More En difference, more group electronegativity. More group electronegativity, you may expect more minus I effect because minus I is directly proportional to electronegativity. We may expect like this. CF3 is greater than Cn. CF3 is greater than Cn. Yes, it is also absolutely wrong. It is also absolutely wrong. What we have to consider here? We should not consider group electronegativity. We have to consider that particular atom. That particular atom. What is this? Is our targeted element. This is our targeted element. So what are the modified electronegativities? Modified electronegativities are important. Modified electronegativities. What is this modified electronegativity? What is this modified electronegativity? So if you want to derive this modified electronegativity, we must know here few factors, hybridization or something. Now one example, among normal friends here. Among normal friends here, completely this is what here? NH3 plus. NH3 plus. Next one is what? N double bond O. Next coordination covalent, which means what is NO2. Next one is what? NH2. NH2. So what is the minus I order? Minus I order. So minus I is exactly depending upon what here? Modified electronegativity. First one is complete positive charge is present. First one is what? Complete positive charge is present. Next one is what? Nitrogen is having partial positive charge. What is that? Partial positive charge. Third one is what here? Partial negative charge. Partial negative charge because N is more electronegative than hydrogen. Of course, minus I is directly proportional to what is that? Electronegativity. So plus is having more electronegativity. That's why NH3 plus is greater than NO2. NO2 is greater than what here? NH2. So this is the order of what? Minus I effect. Minus I effect. If you combine group and elemental, how to find? So here to find that one example here, which means here cyanide is there. Cyanide is there. So what factor we have to consider? What kind of electronegativity we have to consider? So here three types of electronegativities. First one is what? Carbon electronegativity. Simple individual carbon electronegativity. Second one is a group electronegativity. Cyanide electronegativity. Third one is what here? This carbon is connected with more electronegative element, which means it is getting what here? Partial positive charge. So here partial positive charge with sp hybridization. So this is our modified electronegativity. What we have to consider? Think now. What we have to consider? What we have to consider? Elemental, group. Next one modified. No, we should not consider elemental. Next one we should not consider group. We have to consider what here? Modified electronegativity. So what is the C partial positive charge with other substance? Then if you compare C positive partial positive Sp with other, so which is having more modified electronegativity, that is having what? Stronger minus I effect. Okay, this is the comparison. We need here modified electronegativity. So first factor here what? Hybridization. Hybridization of carbon. Modified electronegativity. Of course, here one thing we know, electronegativity is directly proportional to S character. Am I right? Electronegativity among hybrid orbitals, electronegativity is directly proportional to S character. So electronegativity order is what beta here? Electronegativity. First thing is what here? Sp hybridization is greater than Sp2. Sp2 is greater than Sp3. Am I right? Hybridization. So now one example here, C triple bond C. Next one C double bond C. Next one C single bond C. So modified electronegativity of central atom. So this is a modified electronegativity of central atom. I mean targeted element. So this is connected to organic substance. So Sp, Sp2, Sp. More electronegative for more S character. More S character, more electronegative. Then which is having stronger minus I? Alkyne is having stronger minus I than alkene, So this is the first thing. Modified electronegativity. It's based on what? Hybridization of carbon. One more factor is there. One more factor is what? Bond angle. Bond angle is directly proportional to S character. S is directly proportional to electronegativity. Electronegativity is directly proportional to minus I. So this is the overall conclusion based on the bond angles. What does it mean, bond angles? Yes, here also. What is the bond angle here? What is the bond angle beta? 180. What is the bond angle here? 120 because sp2 hybridization. What is the bond angle here? Hydrogen something 109. So more bond angle, more S character. More bond angle, more S character. But if hybridization is same, then we have to find this logic beta. This logic we have to find. So now, for example, here one element is there, A connected with G. One more here A element connected with G. One more here A element connected with G. Now practically maybe it is having like 110 bond angle, maybe it is having 115 bond angle. Hybridization is same, like it is sp3 with 2 lpf. Now here also it is having one example here 104 because of any Vesper theory or whatever. Now see here, hybridization is same. If hybridization is different, then we can find this order. If hybridization is same, then we have to go through with bond angle. So bond angle is directly proportional to minus I. So which is having more minus I? Middle one is having more. Next one is what? This one. Next one is what? This one. So this is the logic of bond angle concept. So these all are modified electronegativity. S character is increased slightly, more bond angle in between these two. This is having what here? More S character, more electronegative. More electronegative is nothing but what? This element, because this is connected to organic substance. So this electronegativity, that is called modified electronegativity. Modified electronegativity is more, so it is having stronger minus side. So this is about what here? Hybridization and bond angle. One more concept is there in bond angle. One more concept is there. This is very important. This one is very important, beta. If you understand this one, then it will be very easy. Now here, this is what here? NB, non-bonding pair electronic repulsion theory. NBPR. So this NBPR is applicable for which one? So if you take here central atom, so central atom should have what? sp3 hybridization. First condition is what? Central atom should have sp3 hybridization. So it should be belonging to second period. It should be belonging to second period. Smaller atoms such as what here? Oxygen. Next one is what? Nitrogen. Because this is what? LP effect. Because of LP effect. Oxygen only may have LP with sp3, nitrogen LP with sp3, carbon of course it is having sp3, but there is no LP effect, na? That's why we no need to consider. So mostly we have to focus on oxygen and nitrogen molecule. Now the connected atoms are then this connected atom, either first at least one, so it should have what? Sag, at least one. Sag is nothing but what? Sterically active group. What does it mean? What is happening here? What is happening because of this sag? What is happening? Bond angle, what happened? What is the influence of bond angle of this sag and sig? Let's see. Sag and sig. Let's see. First one, list of sag. So sag is nothing but beta sterically active group. What is it? Sterically active group. So these are certain kind of bulkier. Maybe chloro, maybe bromo, iodo. Next one is alkyl group, R dash. Next one is like pH. Next one is what? SiR3 type, anything like this. Bulkier atoms. Next one is what? Sig. Sterically inactive molecules. So this is about connected atom, not central atom. These two are belonging to which one? Connected atom. Central atom already fixed. Oxygen, nitrogen. Second period, smaller atom. It should have sp3. Then you must focus on this connected atoms. Now here this one is what? Sig. Sig is mostly second period. This is also second period because smaller atoms. What are those? Maybe OH, maybe NH, maybe fluoro. Next one is hydrogen isotopes. So these all are having what? Smaller size. So there is no sterical repulsion type. That's why these are under sterically inactive. These are under sterically active. So what is this NBPR? One example, let's see. One example, hydrogen, oxygen, hydrogen, which means it is water. Next one is for example, I am taking a pH, okay, not alkyl group, pH and pH. Of course, what is the hybridization? This one is 2LP. This is also having what? 2LP and 2 sigma bonds. What is the hybridization? Both are having sp3. First condition is satisfied. Both are having sp3. What is the central atom? Oxygen. That is okay. Then focus on connected atoms. First molecule is having what? Sig at sag. Sig. Sterically inactive. Second one is having what here? Sag. Second one is having what? Sterically bulkier atom. So what is happening? What is happening here? What is the influence of this one in bond angle? Let's see. One thing we know here, LP-BP repulsions according to Vesper diagram. These two are repelled. Stronger repulsions, LP. Next one, LP-BP repulsions are there. So overall, this bond is getting compressed. So because of this reason, so it is expected to have lesser than 109, which means sp3 hybridization bond angle. Am I right? Is it clear, beta? Because of that one, according to Vesper theory, lesser than 109. But here what is happening? Here what is happening? Hydrogen, oxygen, sorry, oxygen is a smaller atom. Oxygen is a smaller atom having two LPs. That is okay. But here phenyl is actually bulkier atom. Here also this phenyl is bulkier atom. So here electronic repulsions are there. Here electronic bond pair repulsions are there, right? Electronic bond pair repulsions are there. Here also same. But one more repulsions are present here. One more repulsions are present. What is that? The sterical repulsions. What is that, beta? Sterical repulsions, because here oxygen atom is very smaller. Here adjacent bulkier atoms are connected. So these two are having what here? Sterical. Too much sterical crowd. So there is no proper space to accommodate. So that's why what is here? What is the condition here? So NB, this is what non-bonding. Actually here anything, if you take here non-bonding element here. So these sterical repulsions are more than these Vesper repulsions. So non-bonding repulsions are greater than Vesper. Non-bonding repulsions, which means sterical repulsions are greater than Vesper repulsions. So what is happening here? It is extended. It is extended. So because of this extension, bond angle what happened? Increased. Bond angle what happens here? Increased. That bond angle is even greater than hybridization. So if NBPR is present, hybridization comparison is what here? Bond angle comparison. Bond angle is greater than its hybridization. Bond angle is greater than its hybridization. If Vesper is present, normal Vesper. So here bond angle, what is the bond angle order, beta? So if Vesper is present, so Vesper bond angle is lesser than hybridization. Yes or no? Maybe 1 LP, 2 LP, bond angle is 107, 104 something because of LP BP repulsions. So bond angle order is between Vesper and hybridization. What is it? Hybridization is having more. But in non-bonding electronic pair theory, so non-bonding electronic pair theory, bond angle is greater than its hybridization. Now the first one is H2O. What is the bond angle? Lesser than 109. But here PH2O, what is the bond angle? Greater than 109. Greater than 109. So bond angle is increased. Bond angle is increased. Minus I effect. That minus I mean that electronegativity is modified electronegativity because both are having same hybridization. But this bond angle concept is what here? Modified electronegativity. So here PH2O is having more minus I effect. More minus I effect. Actually, this is what here the inorganic molecules, inorganic. But if it is connected, how to apply? If it is connected, like OH is there, next one is OPH is there. Now what is the order? What is the order of minus I? Minus I is directly proportional to modified more electronegativity. Of course, here second, the same logic. So NB is working here, more bond angle, more minus I. In the same way, second one is also OH. Next one is what? OR. Right? OHOR. So here less. This is what? Sig. This is sig. But this one is what? Sag. So bond angle what happened? Increased. If bond angle is increased, modified electronegativity is also increased. So that is the order. That is the order of minus I between OH, OR. So okay, OH, in between OH, OR, which is having stronger minus I effect. What do you think normally here? So actually R group is a alkyl group is a donating capacity, sir. R is having donating capacity, sir. So due to this donating capacity, maybe OR is having lower minus I than OH, sir. No, wrong. That is absolutely wrong. So here modified, according to modified electronegativity, OH is lesser than OR. OR is having more minus I effect. Okay, so this is what modified electronegativity. Let's see few more examples how to find the minus I effect. Okay, right, beta. Now what is the overall order of minus I? multi effects are there: modified electronegativity, positive charge, partial positive charge, sp character, s character in hybridization. Next one is bond angle, that means we may get the modified electronegativity. After getting all these informations, how to find out the proper order of minus I? So here the minus I proper order, the trend of minus I, the strength of minus I, the strength of minus I. First factor is what here? Charge. That too positive charge, because more electronegative, not negative charge. Charge. So here charge, partial complete positive charge is greater than partial positive charge. First on the targeted element which is directly connected to organic cloud, whether it is having positive or partial positive, positive or partial positive. Second factor, if this is absent or both are having same type, then next one is what? Alone electronegative. Alone electronegative. Alone element electronegativity. Alone element electronegativity is greater than group electronegativity. Is greater than group, because of group here EN difference is modified, EN difference is decreased always. So alone element, next one is greater than what here? Group electronegativity. Now the last one is what here? Hybridization. So among that hybrid orbitals, whether it is having more S character or that Vesper diagram or MBPR rule, anyway we have to choose here S character as well as what here? Bond angle, as well as what here? Bond angle. So this is the overall order, overall strength of the minus I order. So one by one example or two sets examples we will see. Now same that use that NBPR. NBPR is applicable for what? sp3 of second period atom like oxygen and nitrogen. Now the connected atom should have what here? Should have SAC, sterically active groups. Okay. Now in between N plus R, R, R. Next one, N plus H, H, H. Yes, both are having same charge, N plus N plus. Of course, sp3. Of course, sp3. Now it is having what here? Spherical crowd is present. Bond angle is increased. Bond angle is increased. Modified electronegativity also increased. Now this is the order. In between Nr3 and NH3, which is more? Nr3 plus is more than NH3 plus. NH3 plus. Now next one. So actually overall order is what here? Nr3 plus greater than Sr2 plus. Same concept if you apply here. Next one is what? NH3 plus. This is the overall positive charge order. Overall positive charge. Many are there, but important factors: Nr3, Sr2, NH3. First factor, positive charge, complete positive charge is over. Second one is what? Partial positive charge. This is very important. Partial positive charge. Now here N double bond O, N double bond O. Next one is what? Cyanide. Next one is what? Cyanide. Of course, what is the charge of nitrogen? Partial positive charge. What is the charge of carbon? Partial positive charge. But here N plus is more electronegative than C plus, because the nitrogen is more electronegative. Positive same. Nitrogen is more electronegative. So modified electronegativity of nitrogen is more than carbon. Okay. And one more important beta here. This is very important. If you assume this is the first rule, rule number 1. Second one is what? Rule number 2. Number 2 rule. Next one is what? Rule number 3 here. Now rule number 3. So if you observe rule number 1 plus rule number 3 with sp character, so this is having more minus I than rule number 2. More minus I than rule number 2. What is the application of this one? See, observe it. First one, rule number 1, rule number 2, rule number 3. Rule number is what? About charge, positive charge. Rule number 2 is what? Electronegativity, alone element, group element. Next one is what? Here, third one, hybridization. So if you observe these two together, including sp character, not others, including sp character, then that is more than second one. That is more than second one. That is more than second one. What does it mean? What does it mean? Let's see. Cyanide, fluoride. Normally, if you think this rule, normally the charge, okay, if you don't observe about charge, na, next one is what here? This is what alone element is there. This is what hybridization. Alone element, after alone element only hybridization, which means fluoride is having more minus effect. No, but what is the charge of this one? Partial positive charge. First rule number, whether it is complete positive or partial positive. Rule number one, what is the hybridization? Sp. Sp. So here what hybridization? Rule number 3. 1 plus 3 with Sp is present. It is having more minus I than second one. So in between cyanide and fluoride, which is having more electronegative, which is having more modified electronegative, or which is having more minus I effect, cyanide. Next one is what? That one only. Cyanide, C triple bond N, CF3, C triple bond N, CF3. So here this is what? Positive charge, but this is sp hybridization, more S character, Now that one we will see. OH and iodine. Previously I told you like OH and iodine. So normally if you think elemental what is the electronegativity, O is having more, but actually OH is a group electronegativity. Iodine is the elemental electronegativity. So which is having more here? I. I is greater than, means all halides are having more minus I effect than which one? OH. Because OH charge is what better here? OH charge is what here? Partial negative charge. Sorry, partial negative charge. Negative charge is what? Less electronegative element. So here one more thing here. Comparison in between O minus, S minus. What is the order? This is actually plus I effect because less electronegativity. Which is having less electronegativity? S minus. Then opposite direction, if you think here I minus order, OH and SH. OH and SH, very important. OH and SH. What is the hybridization here? sp3. Now here En difference. There is no NVPR rule because it is sterically inactive. So OH, SH. OH here more En difference is there. Due to more En difference, it gets what here? Partial negative charge. But here En difference is very small because it is 2.2. This is nearly having 2.4 something. En difference is nearly 0, means I am writing like this 0. Now minus 0. Neutral minus. Neutral is having more electronegative. If neutral is having more electronegative, then minus I effect. See the trend. Both are having same type of trend. S minus is for plus I. SH is for minus I. Very important point, that one. Next one is what here? Group elements. Of course, group element. Now in between OH, OR, already we have derived this one. OR. In between SH, SR. SR means you can take here CSC, which means you can draw like this now. Hydrogen. Next one is what here? CH3. Of course, here spherical growth. You may think here about what sag. No, there is no sag because it is what here? It is not second period element. It is third period, which means already size is increased. If size is increased, there is a proper accommodation, right? So space is increased now. There is no NVPR rule here. NVPR rule is not working. Now En difference we have to select. En difference. These two are having nearly 0 En difference. Now this is having what here? Minus charge. See the trick here. OH, OR, SH, SR. Opposite. OH, OR, SH, SR opposite. But here O minus, S minus and OH and SH both are same. See the logic, right? Now in between these two, OH, OR, SH, SR over. Next one is what? Of course, these two are group because all are partial negative charges beta. Here this is what here partial positive charge. This is what here partial positive charge. Means these two are greater than these two elements. Okay, alone elements are group elements. Next one is hybridization. Now overall conclusion. Overall conclusion is what here? Overall minus I effect. Let's find overall minus I effect. First one is what? Complete positive charge. What is the order? Nr3 plus greater than Sr2 plus greater than NH3 plus. Right? Is it over? Right? So this is over. Next one is a positively charged particle. So positively charged particle we have what? Cyanide and nitro. Nitro is more, right? Nitro is more, greater than cyanide, greater than cyanide, right? So partial positive charge, complete positive charge is over. Will you get anything here? Partial positive charge, nothing. Next one is alone elements. Alone elements among halides we know fluoro, chloro, bromo, iodo. So fluorine is having more electronegative than chlorine. Next one is what here? Bromine. Next one is what here? Iodine. That's it. Elemental is over. Now apart from this elemental, remaining is what here? Group electronegativity. Group electronegativity we have what here? OH or SH, SR. So in between OH, SH again. In between OH, SH is it over? OH now OH, SH. OH, SH. Which is having more? SH. Which is having more here? SH. SH, SH greater than SR. SR. Now in between these two, OR greater than OH. So this is about a group elements. Maybe many are there, but important repeating functional groups are elements. Okay. Now here SR, OR, OH. Next one is what here? Last one, hybridization. Last one is what here? Hybridization. Hybridization again theme is what here? SP is greater than sp2. That sp2, two types of sp2. So you may take here phenyl ring. You may take here phenyl ring. Next one is what? C double bond C. Why? This is sp. Okay. This one is sp. Okay. Here how many sp2? 6 sp2. Here how many sp2? Single sp2. So in between these two, this is having more electronegativity. So that's why phenyl. Afterwards here what here? Ethylene. Next one is what here? Methyl or alkyl. The last one. So here you may take here hydrogen. You may take here what here? Hydrogen. So this is the overall order of minus I. So before that we have discussed already about plus I. Plus I effect is what? Excessive negative charge, lower electronegative than carbon. Next one is alkyl deviant rule. Next one is hydrogen isotopes. Here what is the order minus I? Charge density. I mean more positive charge, partial positive charge. Next one is what? Alone element electronegativity and group electronegativity. Next one is hybridization. Among hybridization, S character bond angle. S character bond angle. So this is about plus I minus I effect. And one more important thing here. So here comparison between carboxylic acid and carboxylic ion, right? So now what is the role of this one beta? This is having partial positive charge, which means it is favors for which one? Minus I effect. And this is having complete partial negative charge, which means it is favored for which one? Plus I effect. Okay, this is okay. Second thing is very important, very important. S double bond O OH. Next one is what? S double bond O O minus. Now you may think in the same direction. Sorry, what is this? Partial positive charge favors for which one? Minus I. More electron density favors for what? Plus I. First one is okay. Partial positive charge is generated here. This is minus I. But the second one is very important. It is not plus I. It is not plus I. It is also minus I. Why? Why it is also minus I? Because you may get the delocalization between any two oxygen atom. Either it is delocalized in between these two or in between these two. Means here the bond would be yes, oxygen, here the delocalized negative charge. Now I am representing with these two carbons. Now this is having like S double bond O. Now this is the S double bond O. Pi bond is a weaker bond. Here it is delocalized. What is the charge of sulfur? What is the charge of sulfur? Partial positive charge. Partial positive charge. Positive charge favors for which one? Minus I. Yes, it is also having minus I. It is also having minus I. It is not under plus I. I have not given in plus I. It is under minus I. Under minus I. So this is the overall information about plus I and minus I. So after knowing these kind of logics, then how to apply? What are the applications? Where we have to apply this one? What we have to find? That we will see in the next video.